Hey, hello everyone. I'm here with Otavio Santana. He's a Java champion. He's the spec lead with JNoSQL, and he's doing a lot of work for Jakarta. So, Otavio, you're very welcome here.
Oh, thank you, Rafa. It's amazing to be here talking about what I enjoy a lot, software engineering in Java, of course.
Obviously, yeah, always Java. Thank you so much for being here, Otavio. It's amazing to have you here. It's an honor. And today we're going to be talking about some things that developers have to do to become a senior software engineer or even to become a better senior software engineer. And Otavio will talk about his insights to help you to become a senior software engineer, or if you're already a senior software engineer, you're going to become a better one. Okay? So Otavio, my first question to you is what concepts should a senior software engineer know very well?
At the beginning, you play around Java, right? I mean, okay, you need to know. Of course, we're going to talk about Java, but in reality, there are several fundamental things that we need to know as senior engineer, or you go even after senior. I would just say that because, on my perspective, when we started our career, we want to go through the framework, learn how to use Java with Hibernate and so on. And we don't want to put a lot of attention in the concepts, in the fundamentals of software, computer science, or software engineering. And that usually is the mistake number one that we do in our career. So, in my opinion, the most important thing that you need to know as senior is the fundamentals. I mean, algorithms, how the decision operation work, how does it work internally. If you're gonna use Java, understand even a little bit the how the JVM work and the garbage collector, things like that. Especially because when you go through this level of knowledge, you're gonna see that it's not Java anymore. It's computer science. We start to talk about the relationship between application and memory allocation with the system operation. And this kind of behavior might have happened in each language that we're gonna use. If you go through the fundamentals of objects, it doesn't matter if you're gonna use Java or Python or C Sharp. Everybody will handle some way with encapsulation, with solid, and so on. Another important aspect around the concepts, it's because it's more immutable. And what does that mean about this? It's hard to change. I mean, if you take a look at the whole Java history right now, we do have microprofile, we do have a new brand of Java EE, that is Jakarta EE. We have Quarkus, Halidon, and so on, new frameworks, new trends. However, the fundamentals are the same. I mean, we still carrying the solid. We still carrying the fundamentals of the persistence. If you go to normalization, it belongs to any language, by the way. We need to face normalization, SQL queries, and so on. If you go through NoSQL database, we need to understand the CAP theorem. That is, again, it goes beyond the framework. Those are concepts that is super important because when we reach a senior, we have more attention to write more soft architecture design, do more soft design, and especially help others. Because eventually, the Stack Overflow is not able to answer you. The ChatGPT is not able to answer you. If those tools is not able to answer you, it's not able to answer your team as well. And guess who? The team will ask about those tough questions. You as senior, you as principal, you as distinguished. And you need to be ready because usually those questions are around fundamentals. Okay, something does not work very well with threats. Sometimes it is operation behavior with threats. Sometimes it's blocker with threads. Sometimes it's related with the core processor instruction with the JVM and things like that. So again, pay attention in the fundamentals of software architecture, understand the fundamentals, algorithms, data structure, software architecture, and so on.
Definitely, that makes you a much better software engineer. And that's what most developers neglect because it's hard.
Unfortunately,
Fundamentals is the hardest. To understand technology, you just read some tutorials, you watch some videos, and there you go. You can develop your own application. But when you go to the fundamentals, then things are much harder. But it's worth it because that's where you become a much better software engineer.
For some reason, we underestimated the power of long term, right? Usually, we don't put a lot of attention in the long term because it takes time to use. I mean, if you learn something about fundamentals, just gonna use it when you become a senior. When the tough issues go through you, the tough discussions go through you, your team will be expecting that you know the answer. And if you don't know because you neglect these fundamentals, you need to run faster to take that information.
And it's not only that, because when you master the fundamentals, you become a quicker learner. You learn much faster because when you know the fundamentals, you're going to see the fundamentals being used everywhere. You're going to see the fundamentals being used in programming languages, in frameworks, in databases, in the cloud. You see fundamentals everywhere. So you become a much quicker learner because then when you see, oh, this thing is just a tool, I know the fundamentals. I know what's going on behind the scenes.
Yes.
Awesome. Thank you so much for your answer, Otavio. So, okay, so we need to know the fundamentals, yeah, and that's very important. But once we know the fundamentals well, what technologies would you recommend a senior developer to know very well in the context of Java?
Oh, the context Java, of course, the primary one, that is a JVM. How does it work? I mean, what is start application? What's happened? What's the memory area? What is the PC counter? How does it work? The difference between the threads. We do have the platform thread that belongs to the system operation. Right now, we have virtual threads. And usually people say, okay, that's amazing, super fast, and so on. But as a senior, you need to understand that everything has a trade-off. Be cheaper as virtual thread does not mean that we will fit in all the scenario. Each scenario makes sense to use virtual thread, and each scenario makes sense to use the system operations threads. Each garbage collector will work very well. I mean, you don't need to go deep on that because there are people who have specialization and performance inside the JVM, but you need to know at least the minimal. How does the JVM work, right? I mean, we need to answer that question. And if you know the JVM and know the OOP very well, everything else you become easier. I mean, okay, each one gonna use Spring or CDI or Quarkus or Helidon? It doesn't matter. The goal will be take the context of the business, convert to objects, and make it a good design with that. So if you're gonna use auto-write or inject, if you are able to use solids when it makes sense, the majority of the time, when you're gonna use strategy partner when it makes sense, has much value than know how to use auto-write or inject.
Awesome.
So go to the Java JVM inside, and that is it for you.
So by knowing the JVM, then it's much easier to learn frameworks. It's much easier to use frameworks, you mean?
Yes, yes. For me, it's much easier to go through framework, especially because the majority of our frameworks right now are using reflection. And what does that mean to our application? What's the trade-off? We need to know that. We have seen several frameworks leaving reflection to use a reflectionless solution. I mean, they avoid to use reflection as much as possible, such as CDI Lite, Quarkus, Spring Native, and so on. So what is the trade-off to use that? There is also GraalVM. What is the trade-off to use that? So each solution inside Java has a trade-off. And you need to understand that very well. Sometimes people just believe that the performance is about the startup, but it's not true. A startup is just one variable inside the performance. I can start very well, but when I get scale, I become slow. Or I don't work with efficiency with multiple threads. Or I consume a lot of memory to start fast, or with the time I become slower than something that starts slower than me. So a long term, I can be faster. So these tiny things makes a huge difference, especially when you go through production and a huge scale product like finance or any kind of product like this.
That's great, Otavio. And yeah, I totally agree to you that if we master the JVM, we will create much better code and we're going to really understand what's going on behind the scenes. And nowadays, we have the cloud, we have microservices, and the applications nowadays, they are much bigger, right? Software developers, they have to write very good code, and they need as well to know about the cloud, to know about microservices, and to know what technologies to use. So what do you recommend developers to get around all of those technologies, and what a senior developer should know regarding
Yeah,
cloud,
that's a good question.
services,
That's a
containers,
good question.
automation, because nowadays it's so much more than Java and code that my question to you is how to understand those concepts more easily and be able to deploy your own application, to be able to automate your application, to be able to build reliable tests, to be able to make your microservice secure. So how to create a good quality application in the cloud?
Oh, that's a good question. And the answer is doing the same code that I'm doing on premise. It does not change. I mean, we did good documentation on premise. We should do it on cloud. We handle with tests, parameter tests with on premise. We should exactly the same in the cloud. There is a joke around cloud that is somebody else's computer. So the idea is exactly the same. So the good code that we write in on-premise, you should do exactly on the cloud. The missing point here is usually people do not understand the concept, like we said before, and try to, okay, let's go through framework. But if you got the fundamentals, you're gonna understand that the von Neumann architecture is still the same, right? The deployment strategy is still the same. Of course, we are using more fancy tools, we are using more advanced technology, but the goal is still the same: delivery product and impact the business as fast as possible. Right now, we do have CI. On that time, we did using Jenkins or something more internally, but the idea is still the same. So to reply that is, okay, learn what you need to know, especially around fundamentals. And when you face that, you will start to run against frameworks, right? Because, okay, I need to learn more about Amazon S3 and then go to Amazon SQS and then go to Google Pub Sub and then go to another cloud provider technology. But if you got the idea of the message queue, those are based on the same concept, for example. So it doesn't matter if you're going to use the Amazon solution, the Google solution, the Oracle solution, so on. The fundamentals is still the same. It's also happened with serverless. What is the idea behind serverless? What is the architecture behind serverless? Of course, each provider might have some different implementation, but the concept is the same. So if you got the idea, you're able to use function as service, serverless in Google, Oracle, and Amazon, because the idea is still the same. So I know that's hard, especially to the junior people or mid-level people, but we need to stop a little bit, understand what you're doing behind, especially to go to senior and then to go beyond junior. And I saw that mistake happen all the time, especially because, as I said, we underestimated the power of the long term, and don't do it. So do a good software like we did with on-premise and monolith. I mean, if you did a good DDD design and click code with the monolith, you are able to do exactly something with microservice, with cloud native, so on. You're gonna have more tools. And remember, even these fancy and most advanced tools provide trade-off. Understand very well. How does it fit?
Yeah, because you can even create a monolith with modules, and then
Yes.
to break it down to microservices is much easier. And the other point you mentioned about the long term, this is important to focus on the long term, because in the fundamentals, because then you have the compound effect. Because the more you learn the fundamentals, the easier for you to learn new things. So you also optimize your time.
Nice.
Awesome. So my next question to you, Otavio, is what is ownership in your opinion? And why this is important as a senior software engineer?
Okay, that's a trick question. But for me, ownership is a deal that you do to your company. I know that people say, okay, you are a company, but you are not your company. I mean, you are part of that. You need to have your reliability as professional, but make sure that there is a win-win situation between you and your company. And make sure that you have your word about these things. I mean, if you agree to deliver a product on Friday, try as much as possible and give transparency if you're able to, or if you're not able to deliver this product, this release on Friday. And pay attention to that, especially because, again, it should be a win-win situation. You should work healthily. Your life is much more than your work. So pay attention to the balance. If the company is breaking these boundaries for some reason or for several mistakes, it is not ownership. It's something else. They are taking too much time. I mean, if you're doing work for free to a company, something might be wrong. Okay, so the ownership for me is a deal between two entities, you and your company. And once both agree in a win-win situation, you're able to move forward and inspire more people to do the same.
Great answer. And can a senior developer ask for help?
Yes, I do it every time. I mean, to write documentation because it's not clear at some point, especially because in IT, there's no standard about the rank level. And a senior engineer might be a principal engineer in some company else, or their company who only has seniors. So it is fine because IT is always change. And another point is sometimes you're able to forget. It's impossible to memorize everything. And I ask you for help all the time, even to check the syntax, to review my code, because I do believe that I don't know all the things. And pay attention with the time. I mean, if you are so much proud of yourself, the point of you want to ignore people that are younger than you, something goes wrong if you. So of course you need to be proud of yourself, of your achievements, of your what you did, but it should not be bigger than your will to learn new things, new technology, methodologies, to learn from your mistakes. And this learning might be for someone that's younger than you. It is fine.
Yeah, I agree. We need to ask help. And obviously, we shouldn't ask for help when we didn't even try. We have to at least try.
Yes.
Yeah, just to see, we can check on the internet, we can check on whatever resource we have. And then if we think it's necessary to ask for help, then yes. So that's important. And what concepts are essential for software architecture, Otavio?
This is a good question. I took it from the New Ford book. That is the fundamentals of architecture, where there are two laws. The first one is the why is more important than the how. I mean, understand first what you need to do. Don't do the mistake of put the technology in the front of the solution. Be a solver lover instead of tool lover. Sometimes you're gonna use Java, sometimes don't. It is fine. How tough, but I just know Java. Okay, maybe it's time to learn a new language, or if your company is bigger enough, to have another team work on this project. I mean, does it make sense to do front end with Java in some case, right? So why not delegate to a front end team instead of do you by yourself? So understand the goal, the achievement, especially because software architecture is strategy. It's not tactic. So the why, the reason, the goals is more important than how you gonna implement it. And the second one is about trade-offs. Every single move has trade-offs. If you are defending Java blindly, if you doubt any issue with Java, probably you're not the best person to take that decision. Because all the change that we're doing in our software every single day are measurable by trade-offs. So if I put Java here, I have the huge community. However, I do have issue to start up with reflection, for example. If I go through JVM, I have the native application that's mean less layers, a good startup. However, long term, I won't have the just-in-time compiler to optimize my application. So every single decision in Java or any software architecture perspective has trade-off, and you need to pay attention to it. Otherwise, you are blind on technology. So somebody else needs to take that decision for you.
That's a very important point. We shouldn't choose technology before knowing what's the problem.
Yeah.
So we need to know the problem first, and then choose the architecture.
Yes, that's what I do believe.
That makes sense. Yes. So what should a senior developer do to stay sharp? I think we talked a little bit
Coding,
about that, but let's talk a little bit more.
yes. For me, it's coding. It doesn't make sense to have a senior principal distinguished who's not able to code. Uh, right now we are discussing a lot of the Y career, where we have the manager path, we have the expert path, and for me, it doesn't make sense to have an expert path who is not expert in something. And of course, you do have experience, or you do have your huge baggage, but you need to keep updated because the architecture that we did 5 years ago is not the same. There are some changes, there are some needs, there are new technologies, and so on. So 10 years ago, we are not discussing about microservices, but right now we are doing. 10 years ago, we are not discussing around NoSQL database, but right now we are doing. 10 years ago, we are not discussing about cloud VM, but right now we are doing. So we need to stay sharp of the coding in the technology. And when I say that, of course, it's impossible to know everything. Choose your expertise. So soft architecture, soft design, high performance application, algorithms, and so on. Understand the market that you're going to take. For example, I do love a lot of computer science, software engineering in a deeper way. So my marketing will work mostly in the open source way, especially because it's not trivial to see a bank building their own database. It's not trivial to see a bank doing some deep computer science. They are usually user of technology. They not build technology. So because I did that decision, I will focus more on this kind of company instead of finance company and e-commerce company. And say that, check the balance between the market as well. I mean, you're able to enjoy, to be expert, something that the market might not have a huge opportunity. Okay, so pay attention to that as well.
Awesome. So how a senior developer get hired by top companies? What is your strategy to be hired by top companies?
There are several ways that I know. For example, you can practice to go to some journey to learn how does the process to the FANG companies work. It is one. I saw a lot of people doing videos that explain a lot about that. But to be honest, that's not my way to do. I enjoy to do a lot of open source. I enjoy the merit to end result. For example, usually when I need to find a new project or to take a new service as a consultor or thing like that, I usually use my results. Okay, take a look here. I did the JVM version 8, or I did this kind of thing. I designed a new persistent API in Java, or things like this. Okay, so with the results, the merit, and because people know what I know, it's much easier than go through the classic process. Of course, you can learn, you can crack, you can hack this process. But be honest, I don't enjoy to waste time doing some whiteboard process, doing months of technical interviews to check if I'm good enough or not good enough. Another issues about that is you need to adapt to the company. And if you go to the open source way, sharing what you know, usually people comes to you because they have an issue that you are an expert. It's much better this way. I mean, you are invited because, okay, Otavio, I see that you're doing a lot of Cassandra stuff. I saw that I'm doing a lot of NoSQL stuff. And I do have this issue with this kind of thing. So let's talk about this and discuss how you can help me on that issue. It's much straightforward than go to the line, and follow the full process. And usually, huge company, the biggest offer is not public, right? They invite somebody else. That's usually what happened, unfortunately. And another point is the merit. I mean, if I do 1,000 of Java certification, I won't have the same merit of James Gosling, the father of Java. I mean, I can have 10,000 Java specification. People will still look into James Gosling as the father of Java because he has the result, he has the merit of doing that, and everybody knows what he knows.
What do you mean that everybody knows what he knows?
Because if you put in the Google right now, James Gosling, you're able to see the entire Wikipedia talking about what he did and about what he does. And probably in the Amazon website, you're able to see what he will do. People knows what he is doing, especially because he's sharing these ideas to social media, to books, to articles, and things like this. So my advice for you is do the same. The Java world has over 9 million people as developers. And this year, as far I know, only 200 people did a contribution in the OpenJDK on the JVM. So if you do a small contribution on the JVM, you will become the number 201 who did this year in the entire world. You will become a new committer of the JVM. Over 9 million Java developers and only 200. It is less than 1%. Hopefully I get this count right. Who is able to say that? It's a huge merit.
Yeah, that's really powerful. That's really powerful. And well, like you said, you have the numbers. Most developers are not doing open source.
Yeah, they are not doing anything. That's fine. Life is decisions, right? As we do with open source, with software engineering, we do have a trade-off. So if you don't go to open source, it's fine. You can be a good professional. It is fine as well. You're gonna save more time because open source, especially in the beginning, it's a huge effort. I won't lie. You need to review and reread a lot of computer science and computer engineering books. I mean, understandable system model operation, how the compiler works, and things like that. So you're gonna away from the classic CRUD operation because they're doing open source work. So, I mean, take the data structure. It may vary, right? I mean, of the product, but usually you have more deep knowledge in computer science. However, if you take advantage of, okay, you are able to do things that the majority of the Java developers are not able to. So for you, it's a highlight. I mean, if I apply to a new opportunity, I probably have 20. And also I mentioned 200 this year, probably just you will have is able to put, okay, I contribute the JVM on the process.
Awesome. Okay, and what soft skills should the senior developer have?
Communication, especially for mentorship. It's impossible right now to write in software without interaction with the client, with the stockholder, and even with other colleagues. Everything is about communication, right? Gunnar had a discussion around writing software code, and he did an analogy between a person who writes very well, who's able to do a clear communication, and who's also able to write a good code. Because at the end, writing code is writing a communication to the machine, of course, but also to somebody else who will maintain that code. It's not only about performance, it's about maintaining the code to make it easier to somebody else, to reliability of the code, and so on. So the communication is fundamentals, critical, especially to the fit, to explain the architecture decision that we're writing, to explain the idea of soft design that we're doing, to help younger people, to guide senior people, managers, and so on. So if we're able to have a good writing communication skill and speak communication skill, both are super crucial, especially when you want to reach post-senior career engineer, like principal, distinguished staff, and so on.
Awesome. And what are the responsibilities of a distinguished software engineer exactly?
That's a good question. And the answer is it may vary, or it depends. Each company has your own rules and regulation. There are companies that does not provide any distinguished rule inside the organization because maybe it's small, or they want to make the career simpler. They put several rules. I know a company that has only senior engineers. I mean, there's no variance between principal, distinguished, and so on. But if you go through the Will Larson book, and also there is this Vin Peter article around the staff engineer, basically we do have the staff, principal, distinguished, and some companies may have fellow engineer. The staff should do the same impact that a senior engineer should do. So mentoring team, guide technology, and so on. A principal should be the same alignment with the director. So impact the whole product, design the whole product, help the whole area, the area of the director, and so on. And the company usually must know you as a principal. I mean, you should help people around the organization. The distinguish, another way, is this rule has some alignment with the VP, usually, right? So the decision might impact the whole company. So it's a super critical area of become a distinguished engineer in the organization. So define a product, define a strategy, define technical strategy in the whole organization, mentoring another principals, doing alignment with another principals, and so on. And when a company becomes so huge, there is also a fellow engineer who will look like a C-level of the company. I mean, you are able to discuss several technical discussions with the C-level as well, with the CTO. So in general, the fellow engineer has the alignment with the CTO. Okay, staff are 2 or 3 squads or 1 squad to impact. Principal, a couple of staffs, each wing a director area. And of course, that includes several staffs. Distinguish the whole company. That means several principals and be aligned with the VP. And a fellow, when the organization is so huge that has companies inside that company. I mean, when you do have like 100 engineers, 2,500 engineers, it's basically several companies inside that company. You do have the fellow engineer.
Awesome. And how to become a distinguished software engineer exactly?
Okay, that's a good question. It's a long-term process where we had several discussions. This may vary again between companies. One good way to go is exploring the open source because people knows people will know what you know. We can say, for example, Emmanuel Bernard, who is distinguished engineer right now by the Red Hat, James Gosling, and those are open source contributor in the world. So open source is a way to contribute and help a lot of with your reliability inside the organization. So go for open source. Sometimes the company will not give the opportunity to become one. So it's time to move up and check other companies' opportunities. And yes, switch company is part of your your career. So don't believe that the company will stay with you the whole time. And pay attention to that. And when it makes sense to stay that company anymore, go for another one. And another advice for you is do interview more often. I mean, okay, you're happy with a company, but there's no crime to check outside the market to see if there is a better opportunity outside.
For sure.
The
It's very
first client of
important.
your career is you, is not your company. So you are responsible for your career.
Definitely. The developer is responsible 100% for their career. And it's highly important to do interviews just to know what's going on in the market because things change. So my last question to you, Otavio, is about your book, Persistent Best Practices for Java Application. Can you tell more about what you wrote and
Great question. Yes, of course, it's a huge pleasure to talk about it, especially because we do have several books around software architecture in the application side, right? I mean, we do have several design partners, we do have several design architectures, refactoring. However, we just have a less documentation and less books around the persistence layer in the Java or any kind of language. The idea of the book is to explain more about this. What's the impact of using DAO? What is the impact of using Mapper? What is the impact of using activity records? What's the impact to use a repository? I mean, every time that I took the decision, there is a couple layers that you put that sometimes you have no idea, but there is impact in your solution. How to use reflection and reflectionless solutions. Each one's best in each scenario. Polyglot persistence. How to solve that. How to use JPA or Jakarta Persistence Relational Database. How to avoid that with JOC. It is one solution as well. So the book will focus more in trade-offs, design, strategy, and partners, and of course, frameworks to handle with the persistence layer with Java. The main goal are senior engineers, of course. We expect that the people already know a lot of OOP and these fundamental concepts to explore more and take more concept inside the persistence layer.
awesome.
And if you want to know more scalability, go for it. And there are several tips on cloud native architecture design with this persistence layer as well.
Amazing. I'm curious to read your book as well, and I will leave the link of the book here in the video so you can get your book because it's for sure amazing. And that's all.
I'm
Thank
super
you.
happy because it's already the hot delivery book in Amazon. I mean, we are in front even of the Venkat book around soft design. So
wow, you are ahead
super
of
excited about that.
Venkat's book?
Yes.
Wow, that's amazing.
Yes, it is.
Wow.
Especially because it is a book that we don't see very often, right? I mean, persistence layers, design patterns, and how to integrate it. And I enjoy a lot writing this book. And of course, I learn a lot writing this book. And hopefully you will enjoy.
Amazing. Wow. That's really, really amazing, Otavio. Thank you so much for sharing your expertise and telling more about your book, because it's amazing. And that's it. Thank you so much.
Thank you, Rafa. It was a usual pleasure. And see you around,
Thanks,
guys.
everyone.
Bye-bye.